Hi, this is Rick. Welcome back. This is Unit 3, and I want to finish up a discussion that we kind of started earlier when we started introducing loops. We introduced the while loop, but there are really three types of loops in C. There is a while loop, a do loop or a do while loop, and a for loop. And they're all very important for different reasons. So the first thing I'm going to show you is kind of a formal definition of a while loop. We've got a count here. The counter is 0. And a while loop is a loop in which the condition is checked at the top of the loop. This kind of loop is called a pre-checked loop. The looping condition is checked at the top of the loop, which means that the loop will loop 0 or more times. So we're going to print out that we're going to be in a while loop. And we're saying while count is less than 10, print count and then increment it. So we've seen this kind of thing before. This is just so I don't have to drop down another line and say count plus plus after I just print the count. Now I'm going to print two lines. So this will print 0 through 9. Now count when we come out of this loop is going to be 10. Keep that in mind. So a while loop, pretty simple. Checks the condition before the loop is entered. The do loop, on the other hand, is a post-checked loop. The condition is checked at the bottom of the loop. That means that a do loop will always execute its statements one time. It'll loop one or more times. So here we're printing out that we're going to be in a do loop. Now remember, count at the time that we drop out of the while loop is 10. So if we say do printf the integer count plus plus while count is less than 10, what will happen is it will go ahead and print 10, check to see if count is less than 10. Well, now it's 11, so it's not less than 10, and drop out of the loop. So again, while loop condition is checked before the loop executes. A do loop condition is checked after the loop executes. That means that if you want the body of the loop to never execute unless the condition is true, use a while loop. The body of a do loop will always execute at least once, no matter if the condition is true or false. The third type of loop is a for loop. Now, for loop has three parts in parentheses after the for. So we have for, and then we have this odd-looking thing here. The three parts are an initialization, int I equals 0. In other words, we're setting an integer to 0. It can be really any type we want it to be. Then we're checking the condition. The loop will execute while this condition is true. So again, we want to count here from 0 through 9. And then I++ is called the increment, how to change the value of the counter. Now this could be I plus equals 97. It really doesn't matter. As long as the condition is true, then the loop will continue to execute. We're printing out, again, the integer value of I each time. So this loop will execute while I is 0 through 9. So let's go ahead and run these three loops, the while loop, the do loop, and the for loop. I'm sorry, I've got a bunch of stuff here. Okay, so this is, we want to make loops, and then we want to run loops. There we go. So we have a while loop counting from 0 through 9, and now the do loop hits that. It gets 10. It's saying do this while the count is less than 10, but it goes ahead and prints it anyway. And then the for loop just goes ahead and prints 0 through 9 again. These are one of the two most important parts of the language. The two most important parts of the language in C are pointers and functions. So here we go, very important stuff. First of all, let's look at main first of all. This doesn't look like it would do much of anything except printf. We have a bunch of things we've never even talked about before. But let's look at each of the functions that I've defined and then see what each of these lines does. So first of all, I've defined a callout function. We can see that function being called here or executed But the function callout has a single parameter, a char star, named string, at least named string inside the function, and then it says void. We haven't encountered void yet. If a function returns no value, then we must say that it returns void. Void means nothing for now. Just accept that. So we have void callout char star string. This means a function that returns no values that takes a single char star parameter named str. All we're doing here is we're wrapping that string, whatever it is, in new lines. So we're going to print a string with a new line before and after it. So when we say call out hello world, we should see new line, hello world, new line. Call out argv0, we should see whatever the name of the program is after a new line and then followed by a new line. So now let's look at a function that doesn't return anything and doesn't take any parameters. This is starline. All it does is print a bunch of stars and a new line. So here we have a couple of calls to starline. Starline, starline. All right, let's look at a function that returns a value, in this case a float, and it's called int2float, and it takes a single value, an int, and here it's called num. Now, this is something we have not seen before. First of all, the keyword return is what we use to return a value from a function. Return whatever we want to do. Well, when we want to convert an integer to a float, one way that we can do that is to cast the integer to a float. This is called a cast. It casts the type of this to a floating point number. Now, this cast to a float is not going to change the type of the integer variable num. Not going to do it. What it's going to do is num as a float. It's going to create a new float and convert whatever is in int into that new float. A cast is a type surrounded by parentheses, just like this. We can generally cast when there will be no loss of precision between the from type, here it's an int, and the to type, here it's a float. So what we're doing is returning a floating point version or a floating point value that is equal to the integer value num. And we call that up here. Where is it? Oh, there we call it. int2float 42. So this will return 42 point and then 6 zeros, because floating points are always returned with 6 digits of precision. All right, let's look at another function. Here's a function that returns nothing and accepts no parameters. So this just counts to 10 and returns. We've seen this a couple of times before. This time we're using a short. Doesn't really matter. We could have used, since we're only counting to 10, we could have used a char type. Short count equal 1. While count is less than or equal to 10, count it, and then print a new line after you're done. So that just counts to 10 and returns. This last function prints a wedge of what kind of character, and the wedge will have number of lines of characters. So here we're returning nothing, and we are passing two parameters, a char called what and an int called lines. I'll leave it for you to understand how this function works, but we'll see it when we call wedge with an @ sign and the number 3. Now, there's a couple of assignments, but I'll leave that until after we run the program. This is functions.c, so we want to make functions and then run functions. Whoops. There we go. So here we have the hello world. It's probably easier to do this if we do it like this. So we're going to call out hello world. Yep, we did that. Well, first we printed a star line. Then we did the call out hello world. There it is. Then we called out argv0. That's the name of the program. Another star line. Now we're printing the floating point version of the integer 42. So int equal 42, float equal 42 point and then 6 zeros. We have another star line. We have count to 10. That worked. And then we have wedge with an at and 3 lines. So we have at. All right, so here's what I want you to do. Couple of things. First assignment is to study that wedge function, understand how it works, and then write and, by the way, call 4 functions like wedge that print wedges in the following configurations. Now, the number sign, it could be any symbol that you pass to the function, and the number of lines could be not just 5, but any number that you pass to the function. So we want a wedge that's printed in the same way as this one. So you could just copy this function, that would be fine. Then we want a wedge that prints kind of right justified. Then we want a left justified wedge that prints in the opposite order. In other words, the largest number down to the smallest number. And then finally, right justify that wedge. That's assignment 1. 4 functions that do something like these 4 diagrams. Assignment 2 is something for you really to think about, but I want you to try it anyway. So the following code snippet swaps the values of 2 integers. So if we have an integer a equal 1 and b equal 2, we make an integer called temp, and then if we set temp equal to a equal to b, and b equal to temp, then a will be 2 and b will be 1 in this case. I want you to try to write a function that does this. I want a function that takes 2 integers, a and b, and swaps their values. I don't want you to print out what a and b are inside the function. That's cheating. What I want you to do is have a function that before you call it, a and b are one thing, and after you call it, a and b are what each other were before you called the function. Can you do it? Were you successful? If you weren't, what do you think might be going on here? And can you think of a way to make such a function work? So something for you to think about. Try this before you start playing the next demo. Thank you very much. Probably. For the reverse wedges, you just need to, for the upside down wedges, you need to count down instead of counting up for the inner loop and outer loop. For the reverse wedges, the trick is to print one less space than the counter and then print the character. So that's a couple ideas that you can use to help you if you had a challenge with that. Now, as far as swapping 2 integers, or 2 anything for that matter, you need to understand before you do that, probably your challenge was that you tried to pass those 2 integers. You knew that inside the function, the values were getting swapped, but outside the function, they weren't getting swapped. So you might have had some thoughts about that, but let me tell you what's really going on. By default, when we pass a parameter to a function, we are passing the value of that variable, the value of that parameter. So let's say if a equals 2, and we say that we're passing a, we're not passing a, we're passing 2. So the value of the variable is passed instead of its actual variable, or instead of the address. This is called pass by value, and it is the default behavior of function parameters. Changing the value, therefore, of a variable inside the function does not change its value outside the function, even if those 2 variables have the same name. This is because the parameters passed to a function are local to the function only. They have what we call local scope. They don't have global scope. And they are local even if they have the same name outside the function. So if we have a parameter, let's say b, that is passed to a function, and if we pass b outside that function to the function, and then inside the function we call it b, they are 2 different variables named v. So when you tried to swap a and b, let's say, when you came out of the function, a and b were 2 different variables than they were inside the function. All right. So here's an example. It's kind of analogous to what you were trying to do with the swap function. So in the main function, let's say that we have an integer a equal 1. And we have a function someplace called add. And what it does is it adds a variable, or it adds the number 2 to a variable. And it's defined as add int a, int b. So here I'm just adding 2 to a. And then if I print, no matter what I do inside add, this is just going to print 1. If we look at the function definition, though, we have void add two integers, a and b. If we say a plus equal b, inside the function, if we print that, it'll print 3. But even after we call add outside the function, it's still going to print 1. Why? Well, because a is 1 outside the function. Doesn't matter if a is 423 inside the function, it still retains its value outside the function. This is the behavior passed by value. Now there's another way. To change the value of a parameter that we pass into a function, to keep it, to retain its value outside the function, we don't pass the value, we pass a pointer to the value. And this is why pointers are so important in C. This is often called pass by reference. Now, if you know C++ or you know some other language where you know the keyword or the kind of entity name reference, this is not the same thing. In C, a reference is an address. So pass by reference means pass by address in C. We are passing a pointer. In other words, we're passing the address of a variable to the function rather than just its value. Therefore, changes to the contents of that pointer, star, persist after the function returns. So this is how we can change values. This is how, for example, hint, hint, we can swap two values and retain their swapitude or their swappiness or whatever after the function returns. So here's an example. Again, it's the same example we had before. So in the main function we have a equals 1. Now let's look at the add function here. What are we doing here? We are adding a pointer to a and b. So if we say the contents of the pointer a plus equal b equals, or if we say the contents of a plus equal b, that means that here, when we come into the function, a is going to be 3, and outside, when we print it outside the function back in the main function, a is also going to be 3. So if we pass a pointer, we pass the address of a, then we can change the value of a in this case. And generally speaking, if we pass a pointer to the function, we can change the value or the contents of that pointer even outside the function. All right, some things to note about pointers and functions. First of all, generally, the name of an array without the square brackets is a pointer to the first element of the array. Just accept that. That is the way it is. The name of a string, a char star variable, is a pointer to the first character in the string. Just accept that. It is true forever. You cannot pass an entire array to a function, but you can pass a pointer to the array. Remember that. That's extremely important. You will try, probably, down the road, to pass an array to a function. You can't do it, but you can pass a pointer to an array. What am I saying here? You can pass the name of the array. You cannot return an array from a function, but you can return a pointer to that array. And, finally, modifying an array or a char star inside a function modifies the array or char star outside the function. Think about the 5 statements I've made on this page, and then think about why this last statement is true. Thank you. Look at an example, and this is the swap example, of passing by value versus passing by reference. So I have defined, or I have 2 function prototypes here, swap v for swap value and swap r for swap reference. In the main program, first of all, I'm attempting to swap 2 integers by passing their values. I have num1 equals 1 and num2 equals 2. I am printing out what num1 and num2 are, and then I'm going to print out that I'm calling swap v, and I'm just going to try swapping by passing num1 and num2 by value, finally printing out what num1 and num2 are again. Then I'm going to try to swap the same two values by passing pointers to their values instead. So I print out what they are. I'm going to print out calling swap r. I swap r with a pointer to num1 and a pointer to num2. And look, we don't have to create a separate pointer. We can just say address of num1, address of num2, and then print out what num1 and num2 are. Now, as you might suspect, the first version will not swap the numbers, and the second version will. But let's go ahead and look at their definitions and see why. First of all, swap v just takes and passes a and b by value. And so inside the function, if we printed out what a and b were inside the function, then we would see that a was 2 and b was 1 after we did our temporary assignment and then swapped a and b. But outside the function, when we print out their values, we'll find out that a is still 1, or num1 is still 1, and num2 is still equal to 2. So that's swap by value, or pass by value, and that will not work. Furthermore, if you thought about maybe there's a way to pass or to return more than one value to a function and tried that, there isn't. Even though we could have returned an array from the function, or actually a pointer to an array from the function, but that's something we're going to do a little bit later when we play with arrays as being passed to functions. So here is the swap or the pass by reference version. Void swap r. Again, we're not returning anything. We are swapping these two integers in place. If we pass a pointer for the two integers, two pointers to integers named pointer to a and pointer to b, then if we set up our temp, set temp equal to the contents of a, then say the contents of a is the contents of b, and then b equals temp, this does work. Because coming in, we are passing the addresses. We are passing pointers, not values. And so what's happening here is that the value in the first pointer is getting the value in the second pointer, and vice versa. Now, there is another way to do it. We could pass in two pointers and just simply assign a to temp. In other words, if temp were an int pointer, then we could just assign temp to a to b, and b to temp without the contents of. And what we're doing here is swapping their pointers, swapping the addresses, not the contents of the addresses, but the addresses. Try it both ways, and then understand why. So, whoops. Try it both ways, and then understand why it works in both cases. So let's go ahead and run this and see how it works. This is functions 2. Make functions 2, and then we're going to run it. Alright, so num1 is 1, num2 is 2. If we call swap v, nothing happened. Num1 is still 1, num2 is 2. Alright, so before calling swap r, num1 is 1, num2 is 2. Calling swap r, something happened. Num1 is 2, and num2 is 1. Understand pass by value and pass by reference, and what is going on when we pass a variable, a parameter, to a function program that allows the user to enter two numbers and then both adds and multiplies them and displays the result. But before we do that, we have a missing piece here. We don't know how to get user input except from the command line, and we could do that, and there are ways to convert those strings that the user inputs at the command line into numbers of whatever format we want, but we would rather prompt the user to enter the first number and the second number, or two numbers separated by a comma, or something like that. Now C has a great number, let's say hundreds of functions in its standard libraries. So what I've done is I've given you a link in Unit 3, and this will be in the code folder, called gcclink.html. And you can just double click this link. It will open up this very simple page, and then you can click the link here, GCC function list, and this will take you to GNU.org's page at manual HTML code functionindex.html. Now, this may seem overwhelming, but first of all, the function names are fairly self-explanatory, and then there's also a list here that shows that will get you a link to other functions of the same sort of thing. So let's just go down here, and what you should do is first of all read through this, and any function that you don't know what it does, you can go ahead and click the function name and see what it does, or you might go ahead and, for example, functions on finding absolute value, you could click here, and this would give you a list of arithmetic functions and so forth. So you can see here there's an integer absolute, there's a long abs, there's a long absolute, maximum integer as an absolute, and so forth. So there are many functions. Now I'm going to shortcut here right down to the one we're looking for. What we want to do is get formatted input from the user, and I will tell you that there is a function called scanf that is kind of the input version of printf. So there are also we can get the link to formatted input functions, but let's just go straight to scanf. So first of all, we can see that here we have formatted input functions, and we have the function scanf. The scanf function reads formatted input from the stream standard in, that is the console, under control of the template using the string template. Template is the same kind of format string that we use in printf. The optional arguments are pointers to the places, they are pointers to the places which receive the resulting values. So now you know why we have been talking about pointers so much. You send them, if you want strings, you send this function char* pointers. If you want integers, you send that int* type pointers, and so forth. The return value is the number of successful assignments. So this tells you everything you need to know, except for one thing: where or what header file is scanf located in. What do you need to include to get scanf? Well, it turns out the prototypes for all of these functions are in the header file stdio, so we really don't need to include anything other than stdio. Now, as you're looking for these functions, you will find, for instance, that if you were interested in some string function, for instance, and they all start with str, by the way, like strcat. This takes two strings and concatenates them. So strcat, for instance, and all of these str functions are in a header file. Here it is. The str and mem, really working with a string in memory and working with contiguous memory, is kind of the same thing. But the str and mem functions are declared in the header file string.h, while the wstr and wmem functions are declared in the file wchar.h. So that's how you find out what you need to include for a particular function. So now we know about scanf, and we're going to begin the program I've written. We're going to add to it here, but this is a short program called numbers.c. It prompts the user for two integers, and right now it adds them and prints the result. It's going to do a little bit more in a minute. We have included stdio. We're going to use the printf function. We're also going to use the scanf function to get input from the user. I've got two function prototypes here that are obviously defined down lower. One is called getInt with prompt, and the other is sum. Here's main. And then I'm prompting, or I'm just saying, I'm going to get now two integers from the user. Int a equals get int with prompt in her first integer, and int b is get int with prompt in her second integer. And now I'm going to print the sum by calling the sum function. So I'll print out whatever a is plus whatever b is, and then the sum of a and b. All right, so get int with prompt is what wraps up our printf and scanf. It gets a char star, a pointer to a character array, or, in other words, a string, and that is called prompt in the function. And I'm going to set up a variable here, an integer called input, because I'm going to return that input here. So first of all, we print out the prompt. Already know how to do that. Now, look at what we do with scanf. We have an integer, that's going to be the input. We use the same sort of format string, but here I'm going to scan in an integer, %d, and because it's an int and this match, I won't get an error. And here I'm passing a pointer to input, address of input, ampersand input, and then finally I return input. So this is really what I wanted to show you, wrapped up in a bigger program. So we're scanning for input, and then we return input, and then sum is really simple. We return an integer. Sum of int a and int b is return a plus b. So we can run this and see that it does work. We'll say make numbers, and there we go, it compiled okay, and then we'll do that, numbers, and enter first integer, let's say 7, and then we'll say 46, and we get 7 plus 46 is 53. Yep, it is 53, so always check to make sure that these are right. All right, so let's now multiply two integers. Well, that's pretty simple. We're going to need a function, let's say product. So really, when we call product, it's going to be the same as calling sum. So we can just, first of all, just say print the product. A comment is always good. And then we'll just copy this whole thing. And we'll do that, and we'll just instead name this function product. So product of a and b. Now we need to add the product function. So let's just say it returns an int. It's called product, and it takes an int a and an int b. And so we'll define it to be return a times b. No surprise there. And finally, this function won't run unless I give it a prototype. So let's put that here, semicolon, and there we go. So now we'll save it, and hopefully we'll get the sum and the product of two numbers. So we'll make the program and run it. Let's say 3 and 12. 3 plus 12 is 15, and I forgot to copy it right, but 3 plus 12 is 36. So let's just change that character. 3 times 12 it should be, and we'll run it again in a minute after we do the next thing. Third thing, let's just say that we want a function, and we can do this in any order, it really doesn't matter, but we want a function to find the greater, which is greater, a or b. So let's just say int, and we'll call this one max, int a, int b. So the maximum of int a, or the maximum of a or b. So again, we don't have to mess with our scanf. Scanf is working properly. We get two integers a and b. So let's just make a comment here, get the max, and again we'll printf, and this time it will be the greatest of, I'm sorry, %d, and %d is %d, new line, and then a, b, and max a of b, a or b. And then finally we'll define the max function. Int max, int a, int b, and here we go. So now to find the maximum, we're going to need to do an if. We're going to need to check which of these two numbers is the max. So we can just simply say if a is greater than b. Now let's think about this for a minute. If a is greater than b, we do want to return a. So that's a one-liner. Return a. So we can just do that. Else, now if b is greater than a, then we return b. What happens if they're equal? We can still return b because the maximum is a or b. So we can just say else return b. And that's a maximum function, and it works for integers. So now let's just go ahead and run everything and make sure we got it all right. Make numbers. Hey, that looks good. We'll run it. So the first integer is 4, let's say. The second integer is 4, and the greatest of 4 and 4 is 4. One more time, let's do something else. Let's say 3 and, 95, and 3 plus 95 is 98. 3 times 95 is 285, and the greatest of 3 is 3 and 95 is 95. And of course, you should run this one more time with the greater of the two numbers being the first number, but I'll leave that